Hi, so 2.3 is a lesson on us doing synthetic, maybe long division, and figuring out what the remainders are of quotient and division problems, and figuring out what that means as far as factors of our polynomials. So this is the basis of the fundamental theorem of algebra, algebra, and we're going to be doing a lot of work. Some of it's going to be familiar, some of it's a little new, depending on your background. So we can divide a polynomial using either long division or synthetic division. The long division is similar to like long division that you learned in 4th grade. But then at some point someone realized like long division is kind of a pain because no one likes to divide and then following that they subtract. So they said, what if we just change the operation to a series of multiplications and additions? And that ends up, that's how they created synthetic division, which means fake division. Turns out it's fine. We just need to break down the polynomial just to a smaller degree. We do have to be very careful about setting up synthetic division. It has to be in standard form. It has to have any zeros as placeholders for missing terms. And then what goes in the box for synthetic division, remember, is the solution to the factor. And we have to be a little careful about that. So like here is a nice example of us using long division of polynomials. I like to put parentheses around that part. And then all you really need to do is find the division of the lead terms of each problem. So we're going to start by taking 3x squared and dividing it by x. So if you think about what happens when you take 3x squared divided by x, that gives you a result of 3x to the third divided by x. The answer gives you 3x squared. Our next step in multiplication, in long division, is to multiply. So 3x squared times this divisor is 3x to the third plus 3x squared. So next, remember 4th grade we subtract now. Watch your parentheses though. First term should always cancel in long division. And then 0 minus 3x squared is negative 3x squared. That's my favorite part, bringing down the next term, because our work is not done. Now we repeat the process. You have a new lead term. Your new lead term is negative 3x squared, still being divided by that initial x, and that gives us negative 3x. We repeat the process with multiplication, this time negative 3x times the divisor. So negative 3x squared minus 3x. And then we are subtracting. First term cancels as it should. And then negative 2 minus negative 3 is negative 2 plus 3. So that's 1x. Then bring down that minus 4. New lead term, x divided by x is a plus 1. And we multiply this plus 1 times the divisor. So that's x plus 1. And then we subtract. And that leaves us with negative 5. Now this last thing we get right here, this is called a remainder. And when we write the quotient, back in Algebra 2 they probably allowed you to do like remainder negative 5. But here in PreCalc, we're going to have to write down what that means. So the remainder is still stuck inside of the division problem. So it's negative 5 still being divided by x plus 1. So you can either say plus a negative 5 divided by x plus 1, or you could take this negative sign and bring it with a addition sign and create a subtraction. So 3x squared minus 3x plus 1, and then subtract 5 over x plus 1. That's probably how the back of the book would have it if this was a book problem and you were looking in the key. So regular Algebra 2 kids have very little experience with synthetic division. Honors Algebra 2 kids have a little more. And if you're coming from college algebra, you should have done a whole lot of it. Now, synthetic division. So we have, was that the same problem? Yeah, same problem. Let's divide this synthetically. So it starts off with like a little half box. Leave some space. This little line here indicates our solutions. We'll go below it. And what you're going to do is you're going to take your coefficients in standard form order and line them up over here. So 3, and then remember we had no x squared term, and then negative 2x, and then a minus 4. Then inside the box is the solution, this linear factor. So the solution would be a negative 1. I really like synthetic division. I prefer to multiply versus divide. So that's just me. We start by bringing down that lead coefficient, and then it's a series of multiplication and addition. So we multiply each of our solution pieces by the negative 1. So it's negative 3. And then we add up that column. So 0 plus negative 3 is, tablet's wigging out at me, huh? All right, negative 3 times negative 1 is positive 3. And then when we add those up, we get a 1. And then 1 times negative 1 is negative 1. What do you know? We get our final number here as a negative 5. This last thing you get is called your remainder. I already kind of knew that would happen. But now what you have to realize is my problem started with a cubic and divided by a linear. So the result of taking a cubic and dividing by a linear is going to be a quadratic. So this first coefficient is associated with the lead term of a quadratic function, and then you go down in standard form from there. So minus 3x plus 1, and then the remainder, remember, is still stuck inside of the division. This time, switch it back to the factor of x plus 1 as the divisor. So either method gave you the same answer. You know, I'm flexible. I don't really care which one you do, unless I tell you. So on a summative, I'm going to ask you possibly to do long division versus synthetic division in some cases. And there are times when long division is more appropriate than synthetic division because of the divisor. So here they would like long division. 2, you know, I'm going to try to color code my steps. That might help. 2x to the third plus 3x squared minus 8x plus 3. We're dividing that by 2x minus 1. All right, so lead term division, take 2x to the third divided by 2x. And sometimes it helps, you know, because these are complicated. If you kind of off to the side, draw out that lead term division. But that's going to leave you with a quotient of x squared. And now we multiply. X squared times 2x minus 1 gives me 2x to the third power minus 1x squared. Your next step is to subtract. The lead terms should always cancel. And they are. And we get 3x squared minus 1x squared, so that's 3 plus 1, so that's 4x squared. And then remember, we need to bring down the next term to continue our division. So I have a new lead term, whoops, wrong color, new lead term, 4x squared, still being divided by the 2x squared, 2x, and that leaves me with plus positive 2x. So we multiply this time 2x times 2x minus 1. Ooh, oh yeah, right color. I'm trying to color code it, but man, you gotta do it right. So 4x squared minus 2x. Then we have a subtraction. Lead term cancels as it should. Negative 8 minus negative 2 is negative 6x. And then bringing down our last term of plus 3. Okay, keep dividing. I have a new lead term. This time it's negative 6x being divided by the 2x, which is negative 3. And now we take that negative 3 and multiply it by our divisor. So negative 3 times 2x minus 1 is negative 6x plus 3. And then remember, we're subtracting that. So lead term cancels, and turns out there is no remainder in this case. So your quotient is just simply x squared plus 2x minus 3. Now, I don't think it says it in this screen, but because the remainder is 0, that tells me several things. It tells me that this particular factor is a factor of the original polynomial. Whoops. Hello. It also tells me that the solution to that factor, which is 1/2, is a solution to this polynomial if I want to go graph it. So it'd be like an x-intercept or some sort of a 0. It might have multiplicity. I don't know without further investigation. It doesn't have multiplicity. I can see from the factorization. We'll talk about that later though. Hang tight. All right, this one again is a long division question. Still on our notes. Let's take a look at that. So 2x to the third power plus 5x squared minus 7x plus 6. And then make sure you put parentheses around that divisor. I just think it helps with the distribution, especially on longer divisors like this one. This is good news though. You're actually going to have less work because of the long divisor. So 2x to the third power, lead coefficient, divided by this lead coefficient would leave me with 2x. And then we multiply 2x times the divisor. So 2x to the third, let's see, plus 6x squared, and then minus 8x. Just don't forget that you're actually subtracting that result. Usually where kids mess up is this step right here. So cancels. 5 minus 6 is negative 1x squared. Negative 7 minus negative 8 is plus 1x. You don't have to put the 1. And then bring down your last term. Man, we're almost home free, guys. All right. New lead term, x squared, negative x squared. We're dividing it by the original x squared divisor, and that gives me negative 1. So now I take that negative 1, and I multiply that by my entire divisor. So negative x squared minus 3x plus 4. Then, kind of weird, but I subtract this to get 4x plus 2. Yeah? Yeah. Something wrong on my key. I'll figure it out. Okay. So that remainder, instead of being a number, it's okay. It happens. But when I go to write my quotient, I have 2x minus 1 and then plus 4x plus 2 over 3, or x squared plus 3x minus 4. So this one doesn't have anything extra weird happening on it. However, you may or may not notice that this remainder has factorization in the numerator and the denominator. So it's not a bad idea for us to go ahead and factor those pieces just in case there's some cancellation. Because once in a while, and I know there's one problem on your homework, if I assigned it to you, I'm not sure, but there was originally one problem on your homework where after we did all this long division, whoops, plus 4 minus 1, there's actually a term that cancels out in the numerator and denominator of that remainder. So that's the answer that you're going to see in my keys. Watch out for that. That happens once in a while. All right, so enough of this long division business. No one likes long division. Talk about, I lied. Okay, there's one more. We're going to just get rid of it, though. Static division. So it's a series of multiply, add, multiply, add, multiply, add. And it leaves you with the coefficients of your resulting quotient. So when you set up static division, you put the solution to your divisor in the box, so negative 4. And then you have to watch out for standard form. So the coefficients are 1, and then there's no x squareds, and then negative 28, and then negative 48. So you always start by bringing down your lead coefficient. And now it's a series of multiplies and adds. So you're going to multiply by the divisor solution. That's negative 4. Add up the column, negative 4. And then multiply again, so that's 16. Then add up this column. So that's negative 12. Very tired. Can you tell with the coffee? So better watch my math. Looks good so far. Negative 12 times 4, negative 4 is positive 48. Well, this is a nice surprise. You end up with 0 remainder. Okay, that's our remainder. So what is the quotient? It is the resulting polynomial with these coefficients. And remember, we started with a cubic and divided by a linear. So that would leave this to be a quadratic. So it's 1x squared minus 4x. And then next would come the constant. There's no remainder. So that's all we're going to write. I love synthetic division. Watch out for this next one. It does have a missing coefficient again. The solution to the factor goes right here. So 1. And then 1. I'm missing the cubic this time. Negative 3. Oh, missing coefficients. Sneaky. I always do a quick check. Whatever the degree is, you should have one more than that as far as terms go because of the constant. So if it's degree 4, you should have 5 numbers lined up in the coefficient. That's what I always do. I am like notorious for losing coefficients, just not paying attention. All right, so bringing down the lead coefficient, and now we multiply, add. So multiply, and then add. Multiply, and then add. Multiply, then add. Probably like your number one favorite thing you learned in Algebra 2. And then multiply, add. So this time we do have a remainder. This last number here is the remainder. When I go to write my quotient, I started with a quartic divided by a linear, so that would leave this guy to be a cubic. So I have 1x to the third, and then plus 1x squared, minus 2x's, minus 2, and then my remainder is 10 over x minus 1. Lovely, isn't it? All right, so just a little tour of long division and synthetic division. So here's the theorem that I was alluding to earlier. If your remainder ends up being 0, that means that that particular divisor was a factor of the polynomial. It also means that the solution to the factor is a solution to the polynomial. In other words, if I plugged it in, I'd get a 0. So that helps us a lot when it comes to graphing polynomials or writing them in factored form. When you are doing synthetic or long division, whatever the remainder is, that is also the answer that you would get if you evaluated that polynomial at that particular value. Like for instance, if I back up to this example, if I were to plug in a 1 into this polynomial, it would give me an answer of 10. So it's actually a very quick way of evaluating a higher level polynomial without the use of a calculator. A lot of people, when they're stuck in a jam, like they don't have a calculator and they need to plug in a value, they'll use synthetic substitution instead of trying to muscle through all the powers. So there's some examples of that. The factor theorem, though, is the most important one to us today. If the remainder is 0, that means that that particular one was a factor. So here, they want to know if x minus 2 is a factor to that. Well, we're only going to figure that out if we don't have a graphic calculator by synthetically substituting it. You could technically full out substitute it, but why? So watch your coefficients. I have 2, 5, negative 14, and negative 8. So if I go through synthetic substitution and I get a remainder of 0, we're in business. I'm going to stop switching colors if it's all right with you. Take your time, guys. All right, so 2 times 2 is 4. 5 plus 4 is 9. 9 times 2 is 18. This added together is 4. 2 times 4 is 8. Look at that. Remainder 0. So the answer is 0. So is it a factor? Yes. There. Theorem. How could we have checked our answer? We could have just plugged in 1. Or on number 4. Wrong question. What was number 4? That guy. So we talked about that. If we plug in a 1 manually, we're going to get an answer of 10. Knowing what I know about teenagers, they're probably not going to go to the effort of double checking their problems. Unless it's a test, then you might. All right, so here, if we figure out who is a factor of the polynomial, we leave ourselves with the quotient answer that is a lower level polynomial that is also a factor. Sometimes it's low enough, like a quadratic, where I can use my algebraic skills and factor it all the way out to linear factors. So that's going to be our hope in this next part, is that we can factor. So kind of giving you a leg up, and I'm saying, hey, x plus 5 is a factor of your polynomial. So I like synthetic the best. So I'm going to synthetically divide this poly by negative 5. So 1, negative 2, negative 29, 30. Now I'm trusting them that that is a factor, and I will know if they lied to me, because if the remainder is not 0, then then I know. All right, multiply, add, multiply, add, multiply. Good news, they didn't lie to us. So here's what's going on. What we have left here, remember it was a cubic divided by a linear, so this is a quadratic. So right now I have x squared minus 7x plus 6. Well, I can factor that. That's x minus 6 times x minus 1. So if I include the given factor in my statement, I can write this cubic in factored form. It's x plus 5 times my new x minus 6 times x minus 1. I also happen to know the 3 solutions. They're at negative 5, 6, and 1. Talk more about that later. All right, this part, for the sake of time, I'm just going to stick to what's on our notes here. I'm going to skip over this one. In class, probably do it. All right, so here. I'm gonna give you a hint for time. Let's pretend I did successive divisions, okay? And I tried putting, 1 inside the box. When I did that for synthetic division on this one, it didn't come out to a remainder of 0. So I'm just going to go ahead and tell you this one does not work. But let's go ahead and try negative 2 in the box, right? Because that would be the solution here. We have a 3, 8, negative 15, negative 32, and 12. All right. Spoiler alert, it works. Let's see. Multiply, add, multiply, add, multiply, add, and multiply. Look at that. Now, for the next one, since this was a yes, I don't have to make a new synthetic division problem. I can just successively divide the next one. So I'm going to do a positive 2 this time on my resulting quotient because it's still in the family of this polynomial. So going through synthetic division on this new one, but you're not going to do the remainder part. Multiply, add, multiply, add, and multiply. Oh, look at that. So yes on that one as well. And then it says, go ahead and write this guy in factored form. Well, remember, this is my resulting quadratic. So if you go through the energy to factor this guy, let's try this, because that'd be 9 on the outside, 1 in the middle. Okay, so there's my other two factors from this resulting quotient. So factored form for f of x would be, remember the original x plus 2 and the x minus 2 that worked great from division. And then the resulting 3x minus 1 and x plus 9. So it's essentially a way for us to break down a really large degree polynomial, break it down to something smaller that, my algebra brain can handle a little easier, like a quadratic. Sometimes you only have to get it to like a 4th degree. As long as it's a trinomial, you should be able to factor it using one of our many methods. So this is one of my favorite topics in algebra and now pre-calculus. We're going to be using synthetic and long division quite a bit. So make sure that if any part of that is confusing, we go through some extra examples together after school or whatever. Just keep at it. I know, memories from 4th grade coming back at you, long division, but this time with polynomials. Good luck.